So yeah, React performance. I just gave the introduction, so this slide is something we're just going to be skipping right now. And yeah, I just thought having a control on renders is a fun name to give it. So yeah, we kind of touched upon it briefly, but why should we care about React performance? I think this is a very, I mean, I don't want to like judge your intelligence by talking about performance, but I think this is very important to understand while we are trying to understand performance in the context of React. So firstly, why should we care about performance? As we talked about before, like we want to increase the stickiness of the app and to drive user growth. So we try to improve the performance so a large variety of users can use the app. And secondly, why do you care about the stickiness? I mean, so these are basically two levels of context. So one level of context is why you care about performance, and that's basically to so that more people can use your app. I mean, you might have heard examples of people in Africa being able to use apps because people move to PWAs, things like that. So yeah, firstly, it's to drive user growth, and the context level above that is why should we even care about stickiness? So the answer is again money. I kind of talked about it before, but it's helpful to know that the primary job of a corporation is to generate money, and whatever we can do in helping in that increases our salaries itself. That's why we have software programmers here to make more money, and of course to help our companies make more money as well. So those are just the two levels of context that you need to keep in mind whenever you think about performance. If your company is worried about, if an interviewer asks you about why should we care about the performance of the app, or if they are trying to coerce you into talking about performance, you can ask them whether performance is even the metric that you need to be focusing on. So that will put a nice interesting spin to the interview, I think. So next up, yeah, right now we are just focusing on performance because that's what I wanted the talk to be about. So what are we trying to solve in terms of performance? There are three main things that we are generally worried about. The first is network optimization, second is rendering optimization, and third is JavaScript optimization. So this is not something that I have made up. This is picked up from system design interviews that for companies like Facebook, Google, etc. And this is actually a good answer for there. So I'm keeping it very interview focused because it's rocket careers. So yeah. So yeah, about network optimization. You can take a screenshot of the slide, or I'll just share the slides with you later on. So the two kinds of optimizations you can generally make in networks are like making the app load faster. So this is something which is generally, I mean, this is something you should worry about when you're talking about low network areas like Africa. India is no longer a low network area, as we know. So this involves things like optimizing your images and optimizing the amount of JavaScript you're pushing to the app, things like that. Second is optimizing the network calls while the app is running itself. So that's generally more like making the app offline first and only having occasional syncs to the server, stuff like that. Second is render optimization. So graphics, as you know, I mean, if you have played video games before, you know how difficult it is to run. I mean, the latest games on your laptop unless you have pretty good specifications. And similarly, it's the case with browsers as well. Your browser, I mean, or your end user's browser can't run your web app unless they have a very good device. As we know, generally iPhone users don't face a lot of problems, but the lower end Android users do. So the two things that we need to take care of here are DOM updates. So I think, I mean, you can ask me about this again if you're confused about any of this, because I think at least these two are like really interview heavy. Like people like to ask questions about these. So DOM updates, why are they expensive? Because they call your GPU directly, and a physical render has to be made on the user screen. So because of that, they are generally more expensive than just updating a JavaScript objects, because you're actually updating the DOM. So you will find good articles on this if you search I mean, you search about DOM, how does a DOM update occur or something like that online. And secondly, it's reflows. So DOM updates and reflows are different because you can actually change how the DOM looks without creating or deleting DOM elements. How do you do that? Generally by changing the CSS variables or CSS values. So it's good to minimize the two of these. And lastly, it's JavaScript. We know that running more JavaScript slows down a device, and JavaScript being a single-threaded application, single-threaded runtime, it blocks the main thread whenever you're running expensive processes. So it's good to talk about this as well. And lastly, why React? So actually, this is a good question, and everyone has a different answer for this. My answer was this. My answer for this was primarily that we are using React because it provides a declarative API for defining the UI. Uh, what this means is like we define a UI, which is a function of whatever state we are providing to it. And secondly, it is mainly to optimize renders by batching DOM updates. So we are coming back to render optimization here by talking about DOM updates. And I mean, reflow will still happen whenever DOM updates, but at least we can try to optimize DOM updates. So that's that about render optimization. So in this talk as well, I will be trying to focusing on render optimization. So to understand the rendering process of React, we need to also understand how React updates. So for you, especially for you guys, I found this very low quality JPEG of a React render online. I'm just kidding. This is the best image that I could find. So I brought this up here, and I've tried to explain. I mean, this image kind of explains how rendering in React works. I'm not sure if you guys were aware, but basically there are two phases: the rendering phase and the commit phase. React initially parses all of the react.create element calls that it gets from the from Webpack or any other loader that you've used, and it generates a virtual DOM. Or a virtual DOM is actually a very bad term, and React also tries to avoid using that. Instead, you can prefer the term abstract syntax tree. So it's kind of like a tree of all of the components or DOM objects that the that React needs to define or which should be rendered to the page. And based on these, in the commit phase, React makes the actual render on screen. And generally, as you might know, there are a lot of virtual DOM objects being generated every time a render is made. Basically, for each render, a new virtual DOM object is generated, and React then, via a process called reconciliation, determines which changes need to be made in the DOM from the differences in two trees, and then it makes the actual change in the DOM phase, in the commit phase. Sorry. So I have an example of this with me right now. It's a very basic piece of code. Let me know if this is going too fast. But basically, I have a simple Next.js app. I'm using Next.js because it's the easiest to get started with. Right now, I have this simple counter here. Like I have a state called count, which which is initialized with 10. And then I have a button which increments the state whenever it is clicked. And then I am rendering a counter component, and which is just displaying the count. But the different thing that I'm doing here is like I'm console logging the outputted element before I'm actually returning it. So why am I doing that? I'll just show that right now. And this is something that you can do with any of the apps that you're working with as well. So if I click on increment, it is changing the UI here, and it is also generating a virtual DOM element. So if we try to open up the console logged element here, you'll get all of its props. I mean, which fiber node owns this, things like that in here. And if we go to elements, I'll just try to move to that element here. So whenever we are clicking on increment, a DOM update is also made. So now if I try to, if I remove count from the counter component, so it isn't displaying anything, but a render is still made whenever set count is called because the state changes. we can see that calling increment, it no longer makes a DOM update. So where we talked about the commit phase, so the commit phase is no longer being called because there are no UI updates to be made. But if we go to the console, then new virtual DOM objects are still being generated. So that's what we mean when we say that there are more render phases than commit phases in general. So what do we get from this? The conclusion that we draw is that we are trying to optimize the rendering phase. The commit phase is something that React takes care of it by itself. So we are going to focus on the rendering phase going forward. So before talking about the rendering phase and understanding it, we need to talk about useEffect and useState as well. So why do useState and useEffect exist? This is another good uh, interview question as well. So the answer is in the documentation for component did update. And component did update was basically a class component function which we used to call to determine when to update state or when to run effects. And I mean, effects you are kind of aware of already. It will effects are things which need to happen outside of the context of your app, like setting or getting local storage data, making API calls, or getting some data from the database. Those are basically effects. So in this example, they have showcased how you can fetch a user's data whenever the prop to a component is changing. Now, as you see, I mean, this is obviously a very basic example that they have provided just to explain how component did update works, but it also teaches us how why class components are pretty bad, because you have to manually compare every prop, and if you had more props that you depended on, you would have to actually physically compare those props as well. Now you know that we no longer have to do that with useState and useEffect, and that is one of the main benefits for them as well. So let me see. So yeah, I think we can I mean, I'll try to go into some of the questions which were asked already. One of which was how many dependencies does useEffect, useCallback, or useMemo generally need to have, and can you remove those dependencies? So yeah, I mean, you guys are generally aware of how useEffect works, right? I guess there are no surprises there, but I'll just create like something called like a test file and just go into that. So let's just define a quick component here. And again, let's just, have the count example because it's the simplest example that one can come up with. I'll just dump that code in here and then render the count directly for now. I guess, although the count itself doesn't matter to us right now, what we are trying to understand is how useEffect works. So the main way in which useEffect and component did update, as we previously saw, differ are that we have multiple state variables, and each of those state variables can be directly added as a dependency to your effect. So this creates more explicit dependencies which have other benefits, like you can actually lint for them, which we'll go into right now. So if add the count dependency here, and in the console, the callback function, I display the count, then I mean, I don't have to run this code. You already know that every time I click on increment, the count will be displayed. But there are cases when I might not pass the count variable in here as well, but React will complain about that. So this is what I was talking about when I said that we can lint against it. And what it is talking about is the React hooks linting ESLint plugin, I guess. Yeah, we can call it an ESLint plugin. And then specifically the exhaustive dependencies rule. So if you go into the actual documentation for it, it gives a pretty good example of how it works. Basically, React wants you to add all of the dependencies for any callback, use callback, useMemo, or useEffect hook that you're using. And if you are trying to add a dependency which shouldn't be used in there, then you probably need to refactor your hook. So in that way, I mean, that kind of answers that question, that you definitely should add all of the dependencies that are being used in there. And in the case of useEffect, React is more forgiving. It allows you to add more dependencies than you want in case you want an effect to run whenever something else changes. But uh, it's not the same case with use callback. So I'll give an example of that as well, I guess. So I'll call this random data for now, let's say. And I mean, I'll just initialize it with something. So we are just trying to look at the linter behavior here. We aren't really doing anything with the data. So if I add random data in here, then ESLint won't really complain about it. But if we use the use callback or use memo, yeah, let's just look at the behavior first, then we'll go into what those hooks actually mean. So uh, say hello, I'll just call this function as say hello, and then define use callback. And console log count. Yeah, I need to console log count in here to display it. But yeah, ESLint starts complaining again. There's nothing when called with only one argument. Did you forget to pass an array of dependencies? Yeah. So if I pass nothing, then it will complain that it has dependency count. Please add it. So I'll go ahead and add that. Now, just as we added random data as the second dependency in useEffect, if I try to add that in here, then Slint still complains because use callback has an unnecessary dependency random data. So why is that? How does use callback and use memo work? Before that, I guess I should talk about why do use memo and use callback exist. Well, firstly, use the hook that we were just talking about here, which is, you know, React, the ESLint plugin React hooks. It forces you to add all of the dependencies, and those include dependencies which might be functions. So say that this was just a function and not a use callback thingy, and we would want this to log the count every time this changed. So again, this is a very contrived example that I'm showcasing here. I think this might work. This might just work. So I'll just console log hello in here. And then if I try to call say hello here as well, let's see what happens. So I'll go to /test, the /test URL, and state is not defined. I'll just quickly define that. What I'm going to try to showcase is how references work. So you might already know, like, we can throw a use effect into an infinite loop by passing in a reference which changes every time. So that can be things like functions or array objects. So yeah, if I put this in here, then React will complain that say hello function makes the dependencies of use effect change on every render, move it inside the use effect callback or wrap it in use callback. So if the function generally has its own dependencies, then you would wrap it in use callback. But let's just see what happens here. I haven't tried this out myself, so let's just do that. Okay. I think that does work fine. I'm trying to figure out how to force it to kind of like go into an infinite loop. If anyone has any thoughts on it, do share them with me. I think it's more like, yeah, so if I don't add the count dependency and if I'm not console logging it, and if I have it as a dependency in here, so what we would think is that say hello would only run once. But since say hello is a function and functions are stored by references, and every time a render is made, a new reference of say hello is generated, the effect runs again. So yeah, I think this is a kind of like a good example of that. So I'll just refresh this, and if I click on increment, yeah, we can see that the say hello function is called every time, even though you might expect that the reference to say hello doesn't change. So in fact, we can kind of maybe try to add count here, but I guess that isn't really helpful for this example. So how we solve that problem is by wrapping it in use callback. And since this doesn't really have any external dependencies, we can just wrap it with a, pass empty array as a dependency array to it. Now, whenever we are clicking on increment, we can see that it is, the console log is no longer being made. So we see the double printing here because since React 18, React is calling effects twice. So that's not something we have to worry about right now. So yeah, that's kind of like an example of use callback. It stabilizes the reference to the function via the dependency parameters. And it does this via a process called memoization. So wait, so those are a lot of terms to think about for you guys right now, I think. So firstly, you need to understand that use callback like stabilizes the reference to a function. And if we talk about useMemo is like is kind of like use callback, but instead of stabilizing a reference, you can, stabilizing a reference to a function, you can stabilize the reference to a value. So for example, if we are getting count in here, again, this is a very contrived example. And if we want to generate the double of the count every time. So what we can do here is like return count star 2. So this kind of ensures that every time we are updating the count, we get a new value of double count directly, and we don't have to use, we don't have to write an effect for that or anything like that. So whenever you are getting data from your props or from within the app, and you just want to get a value out of it, instead of storing it in another state variable. So for example, if I wanted to store another state variable, generally what I would do is like have something like this, and which would be its default value would be count star 2. And then every time I wanted to update this value, I would run an effect which depends on count and then set double count to count star 2. But instead of that, I can just write it inside of a use memo. So I get a stable reference to it directly as well. So let's just print that out quickly in here and adding divs to create a new line. So if we add double count here, and so let's, should we console log it? I don't know if that's helpful. Let's just ignore it for now. Say hello is not defined. Yeah. So yeah, we can see in the same render, it's batching the update for the previous value and the next value as well. So use memo is somewhat helpful in doing that, or for generally for stabilizing references as well. So it does this. React stabilizes the reference for callbacks and use memo via a process called memoization. So you might be already aware of how memoization works, but in things which are generally, in pure functions, memoization becomes possible because for the same set of input, we always get the same output. So double count is a pure function because whenever we are getting a new value of count, for the same value of count, the output will always be the same. So how React caches this is kind of like in a key value pair. So the key is the dependency params, and the value of dependency params at a stage, and the value for that is the output that it returns. So in this case, for count of 1, it is returning 2, So React will memoize just that. So for one, return 2. And if count doesn't change, it always returns the same value. And how does it do that for, let's say we talked about, say, uh, let's say we have a function called display double count, and I rename this to use callback now. And yeah, let's say that calling this function returns double of count. So we can, I don't know, call that function in here, let's say, for example. So in that case, what React does is that for each value of count, so for example, if we have 1 here, then it stores one reference to the callback function, and it keeps this reference table till the count changes. So if it changes to 4, then it will generate this function again, since for 4, the return, I mean, the count, the reference to count here will be different, and it will return that till the count changes again. So that's how memoization generally works. It is basically like a hash map of all the possible inputs and their possible outputs. This is generally only helpful if the output isn't random. So if you have some randomization algorithm, I mean, not a randomization algorithm, but just like a call to match.random in here, then it will kind of break that loop. So you have to keep that in mind. Another key thing to keep in mind for memoization, and something that you can surprise your interviewer with as well, is that the size of the hash map inside of React is just 1. So it doesn't store multiple references. It only stores the one previous reference that it had. And then when a new reference is generated, it throws the previous one away. So this is kind of like an accurate example of how it works. It just stores one key and not more than that. So that's something that you can talk about in memoization as well. And yeah, I think that's the only thing I wanted to cover in this part. But another thing to talk about is state cascades. So I have, I mean, we are going to be talking about memoization here again, as you can probably guess. But let me try to explain the example that I have here. So basically, this is again another counter example, but in here, what I'm trying to do is passing. I mean, I have two components. One is a component which takes count from the parent, and then it just displays it as hey count here. And then I have a second component which doesn't use the prop being passed to it. This is from a previous example, so I'll just remove that. And yeah, what I was trying to showcase here is that whenever the state inside of a component changes, a new render is made, and based on that render, all of the child components and I mean, not the sibling components of that component, but all of its children are re-rendered as well. So because of that, I think, yeah, this should just say parent rendered for now. Uh, Again, to reiterate, I have 3 levels of like components here. One is the parent, one is the first child and the second child, and then I'm console logging whether they have rendered or not in here. And a count is being passed down. So we are just going to have a look at that. If I go to localhost 3000 / state cascade and yeah, try to increment this here, we can see that okay, okay, yeah, because I didn't pass any dependency array to it, I'll just pass count in here, I guess. Although yeah, I need to put that log in the body, not in the useEffect, because otherwise useEffect will try to optimize it based on the dependency params. So yeah, I have the console log in the parent body, so it will be called every time a new render is made. So I'll just refresh that, and every time I'm clicking on increment, we can see that the parent component and all of its children are being re-rendered as well. And that's actually the default React behavior. React doesn't want to, try to optimize your application. It based on which props are being passed to it, it will try to pass all of the props down because it doesn't want to make any assumptions about how your components should work. Perhaps you want them to re-render. So one of the ways that you can actually prevent your child components from re-rendering, again, this is partially helpful only if you have a very complex component that you don't want to be re-rendered every time, is by using the special higher order component from React called react.memo. So what react.memo does is that, firstly, I'll just showcase how it works. What I'm doing here is that the second child, which was just rendering the div second, it doesn't really have anything to do with the count component. So we don't care if it gets rendered or not. So I'll just try to memoize it by wrapping it in react.memo. And now, if I go back to the demo here, and if we click on increment, now whenever we are clicking on increment, only parent rendered and first child rendered is being called, second child rendered isn't being called, because props to it aren't changing. So how react.memo memoizes is like, earlier we were talking about dependency parameters. In this case, it's props. So for all of the props that are being passed to a component, it will always return the same reference, I guess. I mean, I don't know what the perfect way to describe it here is. Probably we can say the same component. So for the same props, it always returns the same reference to the component there. So a re-render isn't made. But so in this case, yeah, we aren't really changing the props to it. It is always being passed no props. So it works the same. But if I pass a prop which keeps changing, so that's what the previous example was kind of about. So pass in account as a prop here, which is changing. And we try to run this again. Then we can see that the second, the child gets re-rendered as well. However, if I make this stable, if I just pass in a solid value of 2, then whenever I'm clicking on increment, the second child isn't being re-rendered. So this kind of like wraps up memoization. There's useCallback, there's useMemo, and then there's react.memo. And another good thing to talk about is probably useRef. So I don't have like perfect examples for it right now, but let's say we are trying to store the mouse position of the user, okay? And I mean, if we try to store a value like this in a state variable, then every time the user changes their mouse value, a new render will be called, and that will be very bad for the system. But if we are just, let me just add that in here. So on mouse move, let's say we are trying to capture it by, yeah, I need event in here, and we store the value of dot mouse position dot current is equal to, let's say, event dot client x and event dot client y. So if you don't know, client x and client y are basically the mouse or pointer position on screen. And then whenever set count is called, we try to multiply the count by the x value or something. Again, this is a contrived example as well. So instead of this, or yeah, let's just say that that remains the same. I call a useEffect in here, and which updates to count. So let's say we console log count star mouse position of 0. I guess it might not exist at the start, but or 1, I guess. So yeah, I mean, this is nullish coalescing as well. I mean, the optional chaining, or no, nullish coalescing, I think. So if mouse position of 0 is undefined or null, then it will pick up the value of 1 in here. User is undefined, that's fine. I'll just add that. So again, I mean, what I'm showing here are the various ways of not using useState directly, but instead relying on the other hooks that React provides to kind of optimize how it works. So this is throwing nan. Why is it throwing nan? Right? Instead of, yeah, I mean, our point here was not to like optimize or fix the bug that I'm just, oh yeah, dot current. That's how we access refs. It's a little confusing without TypeScript, I guess, but it's fine. So yeah, this whenever we are moving the mouse, it is storing whatever its latest position is into the ref, and then on clicking increment, it's multiplying the position of the mouse with whatever the current count is. And this is kind of a good example of preventing renders as well, because it is only rendering whenever we are clicking on set the increment button and not when the ref is changing. So this is also another like stable reference thing that we can use when building our apps. And the next question I got was about context. So there's a lot to, I mean, there's a lot of things that I'm doing here. Let me just like give me a second. I'll replace this with child component. So yeah, about context. What is context? Context is not a state management library, or you probably shouldn't use it for state management. There are a lot of reasons for this. One of them is that any change or any state change in context causes a lot of re-renders that you can't predict. One of the main re-renders which is caused is that basically if the value being passed to a context provider changes, or the component which is hosting the context provider renders, I shouldn't have said changes. I mean, you can replace it with renders there. So if the context provider itself renders or its parent component renders, then all of its child components re-render as well. So this is again something that you wouldn't be wanting out of a simple state management solution that you're using, and this is kind of like unexpected behavior as well. So I have a very simple example, again, the boring count set count. But what I'm doing here instead is that I'm updating set count via an interval of 1 second. And I mean, just to have an idea of how it is working. So we have a context here. If I won't go into the details of how context works, but basically you have a context provider which takes some sort of a value, and then you can access that value from any of the child components of that context. So here I'm passing the count, which is updating based on an interval, and then that count is only being used in a component called grandchild component. I have a component called child component here, which is rendering that grandchild component. And then, I mean, this component itself isn't doing anything. It's again just a contrived example to show you how context and re-renders work. And then child component is called, I mean, displayed inside of here. So again, ask me any questions that you might have about this on in case I'm going too fast with this right now. But yeah, just call this right now and let's see what's printed out. So as we can see, I mean, it might be obvious to you, but since count is updating every time based on an interval, all of the, I mean, the parent component itself is updating firstly because count is updating, which is a state variable belonging to it. And then because of that, the provider is updating, then all of its children are also updating. So that's exactly what we are, I mean, having a showcase of in here. But there's a way of optimizing renders, and again, that's react.memo as well. So here I just use memo instead of react just because I wanted to, I guess. Yeah, there's no real difference there. So instead of the child component, which isn't memoized, if I try to memoize that and then pass it in as the first child to my context provider, now whenever a new render is being made by the state changing, only the parent and the grandchild are being re-rendered. That's because we aren't passing any props to this, and because of that the props reference remains stable and hence it isn't being re-rendered. But why is grandchild component being re-rendered? Well, that's because whenever you are trying to pick out any value out of a context, then whenever that value or if any of the related values change, then the component gets re-rendered. And in the case of context, you might or may not know that you can only pass in one prop for value. And if you are trying to pass in more complex data, for example, if you are passing in an object or an array, then whenever any of the parts, any of the subparts of that array, for example, if in grandchild component, I'm only using the first index of an array, but if any other index changes, then the component will re-render anyways because arrays aren't a stable reference. And same for same for objects. If I use any other key, but then like a random key changes, my component will still re-render. So, I mean, there are other ways to optimize for this by using like React.memo everywhere, but they are generally not recommended because, I mean, it's not, we are using tools like linters and other dev tools just to make our job easier. And this kind of makes our job more difficult. So we have certain state management tools for this, which help to solve this specific problem. So one of them is zustand. So I'm sure that you might have heard or read about this previously. And zustand is very, very interesting because what they are doing is basically they are creating an instance of a context provider outside of your React app, and then they are storing values inside of it. So you don't actually have to define any context provider yourself. I think that they have that written. Yeah, it doesn't trap your app in context provider. So your app doesn't have to worry about context providers. So your app doesn't re-render whenever the state like randomly changes. So you can keep your state outside of your app and then hook into the state via simple hooks that they have provided. So this is the, I mean, this is what I generally recommend. There are other libraries like Redux. Do they have performance applications? I mean, performance implications, probably, but they aren't something that an outsider would probably know about unless they know the very specifics of what kind of I mean, how the library is being used. So in Redux itself, there are like tens of ways like Redux Saga, Redux Thunks, which you can use. And each of them have their own pros and cons. So, I mean, you have to be the best judge of that. But zustand is generally something which you can pick up quite easily. So I recommend that. And I think that that does bring me to the end of what I wanted to share today. Hopefully, like there was a lot of things you could there were a lot of things in here that you could bring to your interviews. But that's it for me. So thanks. Yeah, thanks. And I'm up for questions right now. Oh yeah. If you want to follow me on Twitter at the Writing Dev.